Welcome to my YouTube channel. In this video, I am just continuing the problems which I had done in my previous video. In my previous video, I have explained about initial value problems, and under that Taylor series method I have taken first and explained about how the formula goes and how to substitute, etc. Now in this video also, just another example I am going to give by using Taylor series method. So the problem goes as is: find y at x is equal to 0.1, correct to 4 decimal places, given dy by dx is equal to x minus y squared. And the condition is being given as y of 0 is equal to 1, applying Taylor series method up to 4th degree. So dy by dx is equal to x minus y squared, that is y dash is equal to x minus y squared. And when x takes the value 0, y takes the value 1. That is the meaning of y of 0 is equal to 1. And now they are asking to differentiate up to 4th degree term. So 4 differentiation is required, and then after that we have to substitute and get the value of y at x is equal to 0.1. So let us go for the solution. By data, y dash is equal to x minus y squared, with x naught is equal to 0 and y naught is equal to 1. That means the initial conditions is being given as x naught is 0 and y naught is 1. When x takes the value of 0, y takes the value as 1. And then y dash is equal to x minus y squared. I am just substituting for the value of 0 here. So y dash, what is y dash of 0? We will find out. So y dash of 0 is x of 0 minus y squared of 0, y naught squared of 0. So x of 0 means that x naught it is, so it is going to be 0, and y naught we know that it's going to be 1. So 0 minus 1 squared, that is going to be minus 1. So since we know y dash is equal to x minus y square, let us differentiate again and find out the second derivative of y, and that is y double dash. And after differentiating x minus y squared, I'll be getting 1 minus 2y y dash. And then again I have to find out y double dash of 0 I should find out. So like how we have done in the previous step, same way I have to go for it. And that is going to be 1 minus 2y of 0 and y dash of 0. And then substituting the value of y of 0 and y dash of 0. Y of 0 is nothing but already we knew that it's going to be 1, and y dash of 0 already we found that it's going to be minus 1. On simplification you will be getting this is equal to 3. Then now we have to go for the third derivative. So differentiating the second derivative, we will be arriving the third derivative of y. So 1 minus 2y y dash, I am differentiating again with respect to x, and then I will be getting that as minus 2 into y double dash plus y dash of square. That is, first y dash I have to go with the product rule, and then I have to find out, and that y triple dash of 0, and then again we are substituting the value as y double dash and y dash squared, and when I substitute all this, and on simplification I will be getting that is equal to minus 8. And then fourth differentiation, so differential of third derivative is going to be your fourth differentiation. So on substituting and differentiating 0, and if we get that it is going to be 34. So we know the value of y triple dash, y double dash, y dash, y double dash, all the values I am substituting, and on simplification it is going to be 34. Now let us use the Taylor series expansion. So since the problem is asked up to 4th degree, we are stopping here and applying the Taylor series expansion. What is Taylor series expansion? This expansion goes as such: y of x is equal to y of x naught plus x minus x naught y dash of x naught plus x minus x naught whole squared by 2 factorial y double dash of x naught plus x minus x naught whole cube by 3 factorial y triple dash of x naught plus x minus x naught whole power 4 by 4 factorial y4 of x naught, etc. So since it is asked for only 4 degrees, so we are just stopping here and substituting the values which I arrived earlier. So on substitution I will be getting that as y of x is equal to, we know that x naught is 0, so y of 0, and then x minus 0, that is x, and y dash of x naught means is y dash of 0. So I am just substituting wherever it is x naught as 0, and then y dash of 0, y double dash of 0, y triple dash of 0, etc. So already since we have found everything, the value of all this, I am going to substitute, and then I will be getting that y of x is equal to 1 minus x plus 3x squared by 2 minus 4 by 3x cubed plus 17 by 2 x power 4. So your y of x is equal to 1 minus x plus 3x squared by 2 minus 4 by 3x cubed plus 17 by 2 x power 4. Now what we need to find out is that it is your y of x at x is equal to 0.1, what will be the value of y? So let us substitute at x is equal to 0. So wherever you see x, just replace it by 0.1, and then on simplification you arrive that y of 0.1 is equal to 0.9145. So that is the solution for this problem by using Taylor series method. Thanks for watching. See you in another video.